Alright, today's daily 2044 count number of maximum bitwise-OR subsets. Given an integer array nums, find the maximum possible bitwise-OR of a subset nums and return the number of different non-empty subsets with maximum bitwise-OR. Sorry, I need to turn down the TV. I've got friends going. An array A is a sub. Okay, find the maximum possible bitwise OR of a subset of nums, and return the number of different non-empty subsets. So, for example, if you have 3, 1, you do bitwise OR, and you get 2. And then the maximum possible bitwise OR of a subset is 3. There are 2 subsets with a bitwise OR of 3. Okay, yeah. Okay, well, the maximum, since it's OR, it's not AND, is always going to be bitwise OR. The maximum is always going to include the total because, yeah, they have to be 1 or more. So if we bitwise OR all of them together, then we'll definitely have the maximum. So now it's just a matter. Okay, so that's my first thought is find max by ORing all the numbers. Which I believe is just one line. Yeah, okay, just double checking. Okay. So then it's just a matter of what subsets contain all those digits. This one's gonna be tough, actually. Okay, so that's my first thought is find the max. So what if we just do that? That only takes one pass through. So for num in nums, we'll say okay, so num's length is going to be from 1 to 16. Okay. Well, first we can say if the length of nums. We'll do that edge case because we're going to be ORing the nums. But if the length of it is 1, then it's just going to be return 1. So edge case can't OR with only one num. So we get that out of the way. So now my thought is we'll say max OR is nums. We're guaranteed to have at least 2. So say nums 0 or nums 1. All right. So for I in range, since we've used up the first two, we can start from 2, because 0, 1, 2, and we go till length of nums. Why don't we hold on to that? Use up a little space, maybe save a billionth of a second or something. So now we say max, or can we just like, can we... Yeah, okay, cool. So we can say max or, and we'll just basically accumulate that. I should probably start to get more of a direction of what I'm going with here. But now we have max or, and now we know what the maximum is. We just need to build our way up to it. Now the brute force way would be to just, you could, okay, brute force solution would be to take all, would be to decrement k as you, we'll say k equals n. Let me make that n. Yeah, n. I like that. That's a common size. K equals n minus 1. And then you decrement k. Decrement k as you calculate all permutations of size k. If none of those equal max or, then stop the loop. Okay? I mean, the constraints are pretty tight. I don't think that this will work, but that's my thought basically, is that like, if you can't make the max with a if you can't make the max with a bigger number, then there's no point in even trying with a bigger subset. There's no point in even trying with a subset, because OR is only an additive. And if you're trying to get the highest possible value, then removing a value will never get you closer. So you could use iter tools. Sorry, Friends ended and Big Bang Theory came on. There we go. Got Impractical Jokers going in the background. We're good. This is the one where they get tattoos. That's crazy. Okay. Brute force solution. So this would probably take too long. But we can import iter tools. Yep. Just double check. Okay. So what we could do is we could say give me, we could say k equals n minus 1, and we'll say for I in range, I don't know, 1 through, or yeah, k, we'll say 0 through k, actually 0 through k plus 1, and we're, actually we'll just say k equals n. So now we have this range. I is the number of elements that we're trying out. And we'll say found 1. Actually, why don't we just say we're going to need to keep track of the maxes. So now we'll say so actually it's going to have to be 1 through k, because you can't have a, it's got to be a non-empty subset. So max is equals at least 1. And we're going to say, so now we want to loop through and calculate the permutations. So we'll say maybe we make a helper function. I just so this will work. I think it'll take too long. We're going to say for subset in list itertools permutations nums I. So for every subset in that list of yeah, so that will give us all the subsets of decreasing length. We'll say new maxes Okay, so we can I'm going to reset this. Okay, so n equals length of nums. Okay, so we have this edge case. That's the same. I think that we can use a library to save some time here. Since we know there's at least two, we're going to say max OR equals functools reduce we're going to go through all the values. Okay, and do that. Okay, so that's the max number of OR, the maximum possible bitwise OR of that subset. So now we just need to see all the different values that add up to that. So we'll say for k in reverse range, or we could just step backwards. We'll say range. We don't want to do 2. We'll do a special case for the ones. N. And it's exclusive, but we don't care because we already did the total. And -1. Okay. Actually, sorry. N minus 1 through, wait. To 1. Okay, we're going to start stop step. Okay. And this will actually stop at 2, but that's okay because we don't want to try to run this. I guess we could try. Okay. Max is equals 1. Okay. Now we'll say we're going to say new maxes equals maxes, and this will stop the recursion if new maxes equals maxes. Then that means that we can break it. And then return maxes because it's only ever going to get smaller and we have a decreasing subset. So, yeah. Break. Otherwise, maxes equals new maxes. So basically, if there was no change, okay. Now we can say perms equals list itertools permutations nums k. All right. And for perm in perms, or actually we'll say subsets. For subset in subsets, if, okay, count equals functools reduce subset, and new maxes plus equals count. Oh wait, no, we say, sorry, no, that's assuming it's a number. If functools reduce equals max OR, then new max is equals plus equals count. Done. Okay, then we say return. That'd be crazy if this worked. Okay, well this expected 10 because 2 is 1, 0. So we have 3 of the same number, so it should be 1, 2, 3, 4, 5, 6, 7. Instead we got 10. We'll say, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it doesn't do the ones the wrong amount of times, but it does do this twice, unnecessarily so. Let's say oh, permutations. No, I want combinations. Really? That works? No way. I'm really surprised that worked.